Let's move on then. DAOS with standard interfaces, middleware. So as I said, we have this POSIX container, and the question is how do you integrate it with your application? So at the bottom, you have the DAO storage engine. We have 1024 node, 2048 engine on Aurora, the DAOS library, DFS. Up to there, everything is fine. And the question is like, okay, I have my application. It's doing file open, file close, with the libc, and how do I integrate it with this user space library, right? There are actually three ways that you can use a POSIX container. The first way here is basically you link your application directly with libdfs. That's the most intrusive way, right? But you link directly with libdfs. You don't use the libc. Instead of calling open, that will be provided by the libc, you change your app to call dfs open, and you link with libdfs. That's the most intrusive way, right? But the most performant, maybe to some extent, to integrate it with your application. Low latency, high concurrency, all you process, you will load libdfs and libdaos, and you will have the maximum performance. But obviously, not everybody can do that, and we don't necessarily recommend for people to do that to start with, for sure. So there is, at the opposite side of the spectrum, the other approach where you can just do what I presented into the previous slide with Fuse, right? Fuse is a user space file system that basically a daemon that registers a mount point to the Linux kernel that is then exposed to the application, right? So in this case, previous example, I mounted diffuse under tid/DAOS, and then tid/DAOS on my home directory was the mount point, and then everything was mounted there, right? And then you can access with Fuse, you can cd, ls, run the application in parallel. You just have a traditional mount point like you are familiar with in Lustre, except that the daemon is in user space instead of being in the kernel, right? That's the opposite side of the spectrum. Very friendly for users, but not necessarily the most performant way as well, right? Because it's a daemon, so the path is that your application goes through the kernel, the data is copied to the kernel, and then copied back to the diffuse daemon, and then the diffuse daemon only after that send it with libdfs to the storage engine. So there is a lot of copy back and forth between the kernel and higher latency as well, because when the Linux kernel queue the IO to the diffuse daemon, you need to wait for the diffuse daemon to be scheduled in order to send it, right? So friendly, but not the most performant one. So this is why we also introduce a third way where we combine Fuse with an interception library with LD preload. That is called PIL for DFS. So it provides the same performance as one, right? As using rewriting your app to call libdfs directly, but with no application changes. We use LD preloads, we intercept both metadata and data call. And we need Fuse still because there are some calls that are handed off to Fuse, right? Like for instance, if you want to do mmap, it's very difficult to do mmap in an interception library because you need the kernel to provide the region. There are ways to do that, but not necessarily super efficient. So in the side, it's definitely more efficient to rely on Fuse and rely on the kernel infrastructure, right? So we came up with this hybrid model where you can intercept and provide a bypass, having the data sent to the wire as quickly as possible from the application with the interception library, but still supporting a mount point that is friendly and supporting a map through the mount point. Those are the three ways, and now I think we're going to dig more into this. Mohamad,
I have
welcome
a
back.
quick question.
Yeah, sure.
Yeah. So if I have a file that's, let's say, written with mmap,
Yeah.
what is then the best way to write that to DAOS?
If you have a file right onto mmap, you should just use Fuse because most of the work is going to be done by the kernel with mmap.
I see. Okay. Thank you.
So mmap, the kernel gives you pages, and then it track dirty pages, and then it write them back in the back, and so on. And
Yes,
I think Fuse is the way.
I see. Okay, great. Thanks.
Ahmed, you are ready to take
Hey,
over the
so
sharing?
you can see my screen?
I cannot myself, at least. Nope.
No?
I see it.
No, I can see it too.
That
Yeah.
must be me then. Okay.
Okay,
I
sorry,
will
Johann.
rejoin.
Okay, so before carrying on quickly, just to go back to that NIC assignment and CPU binding, I will share like here a nice map from Kaushik presentation to show like the recommended CPU binding that you can use on your MPI run command, MPI exec. If you're using like 12 ppn, and this table tells you like where each core binds, like goes to what NIC and so on. So basically, that's like one of the recommendation if you use 12 ppn. I think Kaushik probably has more examples for 16 ppn, 32, 64, and so on. The only thing to note is that on Aurora, using core 0 and core 52 have been disabled, so just keep that into account. Otherwise, you probably want your bindings to be distributed to use all NICs on both sockets. So I just wanted to circle back to this because Kaushik had a nice slide on this to show that, and the recommended CPU binding to use, which works well as we've tested. Okay. Going back to this, so Johann went through this slide to explain sort of the different POSIX access scenarios that we have. And I will dive into details now on how to use each one and what is needed. I'm going to skip the DFS direct part because that probably takes time to explain all the libdfs API, and probably more for advanced users. So we'll focus more on the paths that do not need any application code changes, but using the libdfs API, or somebody was asking before about the array API or KV API. For advanced users, you are welcome, and it requires some work to write the change to use the libdeos API, but there are some gains to be made if you know what you're doing, and you can properly map your data model to the underneath libdeos API. I think that's one way to go, but probably requires more help from DAOS engineers or others who are familiar with the DAOS API to help on how to use that API. The DFS is easier because it's very similar to POSIX, but it still requires application changes. And there are a lot of examples on our documentation if you want to use the DFS. But today we are going to focus through POSIX using diffuse and interception library. Let me switch here. So diffuse. So as I said, DAOS provides this diffuse daemon where you can mount a POSIX container on all the clients at a specific path. So once you do that, your DAOS container becomes essentially a parallel file system like Lustre, GPFS, or anything. So when you start, you get your allocation, your compute node allocation. You have to mount your container on every client node where you want to access that path from. This is all in user space, so you don't have to have any elevated privileges to use the mount command. You do need access to the pool and the container that you are accessing, of course. If you do not have permission to a pool or a container that you want to mount, you won't be able to mount it. Once you are done, you can unmount diffuse, but you don't have to, because there's a process in the PBS epilogue. Once your job is canceled or exits, it will do it automatically on Aurora, basically. So how to mount and unmount? There are several ways. You can do it manually, as I say here, with Clush to your PBS nodes, and specify a specific path where you want to mount it. You mount your diffuse on, and unmount it manually. But on Aurora, there are some commands, that scripts basically that that you can use on the login node and on the compute node. For that, I will actually switch to use Kaushik slides again because it has more information. From the if you are on a UAN, the login node, you can create a directory using your username. You don't have to use the pool and the container. You can call that anything. You can call it, for example, temp, your username, and diffuse or DAOS or whatever. And then you call start diffuse with that path, your pool and your container, and you will have access to that container, to that mount point. And once you're done on the login node, you need to do clean diffuse. There is no PBS on the login node, so you have to clean it. Otherwise, you're going to leave stale mount points at some time. So yeah, please make sure if you're doing on the login node to be able to do that. From the compute node, you can use once you do module. Once you go, do module use, module load DAOS, and you have your container created and all of that, you can call the script called launch diffuse, and it will, with your pool and your container, and it will mount it on all your compute nodes. So this launch diffuse script does the PDSH or flush to all the compute nodes. It will mount diffuse for you, and it will return when it's done. And once you do that, you can validate that your container is mounted, doing mount and grep for diffuse at that particular location. You can do ls, cd, and do all that stuff that you want on like a regular file system. Any questions so far? And yeah, please stop me if we can. This can be an interactive. I don't need to. I don't need to wait till the end of the session to take questions, so please stop me at any time. I'm not sure if I have, I can see the chat, so if somebody posts something in the chat, please let me know so I can, or please get the question for me. For mount options, you can, there is, by default, launch diffuse will do disable caching, basically client-side caching. This is always required if you're doing read-write from multiple nodes, but you can modify that script if you want, copy it and modify it to remove disable caching if you are running on a single node only, or you are doing read only. The diffuse client will do some caching to improve performance a bit, if especially in terms of small IO, but usually that's not really needed unless you are doing some particular workload that's reading the same thing over and over again. That might be useful. Yes, so here, one do you use diffuse basically for normal file system operation. If you just want to look at your namespace, ls, see what's in there, and you also you have your app and you want to specify paths or a current working directory where you want to do your IO. That's what diffuse is good to. Another thing, it's like if you're doing something just node local only on a single node, caching will help there because diffuse implements caching through the kernel basically, and through the diffuse itself. It might require some tuning of some attributes container, but if that's your use case, we can talk offline more on what those attributes to tune are. But basically, if you're just running on a single node, doing very tiny IO and things like that, it might be a good idea to work with caching enabled, and especially write back and read ahead caching. I think that works pretty well. But remember, if you're doing multiple nodes and you read write, caching will not work. It will actually can harm your data, can cause maybe corruption, or you might not see things in time. It breaks POSIX semantics basically if you do that. So performance of diffuse is very limited. You do not use diffuse by itself only for if you're doing hundreds or thousands of client runs, and you expect a large bandwidth, high bandwidth, and high IOPS number. You won't get that just with diffuse. You need more you need to use, diffuse in combination with the interception library, as Johann explained later, or I explained before, or using the MPI IO driver, which we'll talk also about, and we'll talk about both in the next few slides. You can, before we go into multi-user diffuse quickly, as the question was asked, if many users can mount the same container. Yes, you can. If everybody have access to the container on their separate compute nodes, or even the same node, you can mount that same container on their separate paths for different users, and they can all work on the container together. That's no problem. But there is another mode where we call multi-user diffuse, where you can mount a diffuse on a single node for many people to use, like on a single mount point, single container, single path. That usually doesn't make sense to use on compute nodes, but it can make sense to use on the login node to share, a root container with everybody. But again, this is not to be confused with the mode where everybody can mount their container themselves on different paths. That's different, right? This requires special privileges and usually is done, by the sys administrator, because it needs maybe a dedicated account for this to mount the container. So I don't expect users themselves to use multi-user diffuse, but they can each mount their own container themselves when running on the compute node. Any questions? Okay, so to use diffuse with the interception library, so
Mohamad, I see one in the chat.
Yes.
It says the mount point in the slide is not the default one in the compute node. I guess maybe it's a comment. It's not a compute node, right? And then temp DAOS _ pool DAOS container is used on compute node by default. So that's, I guess, maybe a question.
Yeah, the script, Mohamad, the script that are used, the launch DAOS, launch diffuse and clean diffuse one on the compute node, they mount on TMP DAOS pool DAOS count, right? Which I think was different from what you gave and from what I gave, right? We use a different mount point because we didn't use those two scripts.
Yeah. So I think this slide from Kaushik is the correct one, and the ALTF documentation will update that.
Mohamad, if I could just add a note. So just to clarify, users could choose to mount things anywhere they like. LCF created some of these scripts just to make things easier for the users. So they assume some defaults and things like that in order, hopefully, to make it easier. But you could, of course, choose to select your own mount path if you wanted it to be, for example, mounted in your home directory. You could choose to do that.
Yeah. So if you use the launch diffuse, it will mount it here. But as I said, you can mount things manually on basically any directory that supports extended attributes. that's where how it works. So you can use the diffuse mount command that I explained that I have here and choose any path you want, right? This is different. This is doing things manually, and you can choose this path here anywhere you want. If you use launch diffuse, it will mount it on maybe there's no user here, just temp pool container. Make sense? Can DAOS container be mounted on Windows system? No, we do not support Windows. Sorry.
I'm aware of one person who did it in the past, but no, we don't recommend it.
Okay. So interception libraries. Historically, DAOS provided 2 interception libraries, and that's what's available today. One, what we call libIOIL, it just intercepts basic IO calls: read, write, p-read, p-write, f-read, f-write. Basically, it was just for IO, raw data, not metadata. So if you do libIOIL, things like file creation, file deletion, stat, all that stuff goes through Fuse, and IOIL will do user space IO basically only. And then we later introduced this interception library that's most used today on Aurora, the PIL4 DFS. This is more complicated because it intercepts all glibc, sorry, there's a typo here, and handles most file operation data and metadata through user space and the DFS API. So why do we have two, and why didn't we remove the first once we introduced the second? So first of all, we wanted the second because the first one, the IOIL, was insufficient for many use cases. There are still metadata heavy workloads that were not having good performance because of the interception of IOIL that does raw data. Pill for DFS addresses most of this issue, but as I said, Pill for DFS intercepts all glibc calls. So it was a little challenging in its own way to go through all calls and make sure it works well. We are at a point, I think we are confident that this still works well. There are still some issues that I'll talk about in troubleshooting section, but Pill for DFS, I think, is a recommended way to what we use today on Aurora. And how to use that in your MPI exec, you can add a genv LD preload and the path to Pill for DFS, which is this one on the compute nodes, and then you run your application. Please avoid usage such that you always export it in your environment. The fact that it intercepts all glibc calls, if you do something like not related to IO or application, it still gets intercepted, and there might be some issues. For example, we've seen some issues with libce that's unrelated to any IO or your application. Other issues with Python stuff. It should work if you do it that way, but we haven't tested all scenarios. So please avoid, just always setting it in your environment or before your application starts. Now, some applications don't run with MPI exec. Doing LD preload followed by your application binary is also fine. That works fine. So some popular questions and concerns when using Pill for DFS. Do I need diffuse mounted if I'm using Pill for DFS because it's it intercepts everything? Yes, you still need diffuse mounted because there are some things that we do not implement in the interception library that we defer to diffuse. Johann talked about mmap, things like that. So yes, you need diffuse mounted while using interception. So the other question is, I don't know if interception is working or not. How can I tell? You can add an environment variable called DIL report one, and then it will print a usage report at the end of your program. This is a per process setting. So if you're running with 1 million process, you'll get 1 million, a lot of output. So try to set it only for rank 0, for example, through some MPI exact magic that you can do, and it will do a report on what has been intercepted. Sometimes you get an error like this: operation not supported when using Pill for DFS. This means like we missed some glibc function that we did not intercept. You can get around that by doing export DIL compatible = 1. I'm not gonna tell you what it means. Just do that. But what I would ask you to do to please contact somebody on Slack or somebody anywhere on the Aurora, any of the Aurora channels, to maybe explain what this operation is, or give some log or something, so we can investigate it and resolve that issue, so you don't have to use that environment in that case. And does that make sense? Any questions? I see there's a question, but it's being answered by folks, so I'll leave that there. Okay, if not, we can move to how to use MPI IO. And MPI IO is probably very widely used, like probably the most widely used on Aurora, because other than it's part of the MPI standard, it's a building block for many of the parallel IO libraries that many people are using, like HDF5, PNetCDF, Adios. Everything usually has some building block on top of MPI IO. So why is MPI IO good? Just to give a brief overview, it does collective IO, collective optimizations basically. Like if your IO is very irregular, not optimized, from all your processes. MPI-IO has this process called aggregation and two-phase I/O and things like that, where it collects data and optimizes it for the file system. It also provides the notion of collective file create and file open if the file system supports it, which DAOS does. So you can instead, if everybody is trying to open a file, and you have like 1 million process running, you don't have to have everybody go to the file system to open the file. Only one process instead of 1 million, million process pounding on the file system to open just a single file. One process can open it and broadcast that handle to the other processes. There is other different access pattern that you can do with MPI-IO with derived data types and file views. I won't get into that. But chances, if you are doing parallel I/O on Aurora, your app has an MPI-IO backend or one of the HDF5 Peanut CDF backends that use MPI-IO. So yeah, this is very important to support well on Aurora. So how does DAOS support MPI-IO? So DAOS, if you use the MPitch that's installed on Aurora, there are many MPitch versions installed. All of them, have this the DAOS ADIO driver. But the MPitch implementation for MPI-IO, which is called ROM-IO, it has lower level drivers for different file systems. There's one for Lustre, PVFS, the old PVFS2 stuff. There's one for DAOS, but there's a generic one called UFS, which just use basic POSIX call for all that's supported over most POSIX compliant parallel file systems. So if you use UFS driver, it works with DAOS through diffuse. That's not a problem. But DAOS also provides an ADIO driver that's installed with MPitch on these MPitch versions on Aurora. So this completely bypasses diffuse and the POSIX API, and it uses the DFS API directly. So if you're using MPI-IO, it's like using the DFS API directly without application changes. That's a big win. What's another so why also use this driver instead of the UFS driver? This driver provides the collective file create and open. So if you do UFS driver, does not. Every process will go open or create a file to when they want to get a file handle. All processes will talk to the file system. But when using this driver, only one rank talks to the file system and broadcasts the handler. The other optimization, it has a list IO interface, so there's no read, modify, write at all. So that's optimization that works well in some cases, maybe, but not so well in other cases. It depends, but mostly it works well. How do you want to use your DAOS driver? You don't have to do anything. Today it is by default used when DAOS detects you're using you're accessing a diffuse DAOS file system or diffuse. So MPitch will detect that the file system is based on top of DAOS and use the driver by default. It used to be not the case. You used to have to set this environment variable to use that, but that's not the case anymore with the latest DAOS installed on Aurora. This has changed, and it will automatically use that driver. No application code changes are needed in that case. So do I still, again, the question is, do I still need to mount diffuse? Yes, application still needs a path to the file. Diffuse gives you like this namespace or a current working directory where you run your application from. So to provide that path to the file, you need diffuse. Diffuse is not used for I/O, but you still need MPI, the ROM-IO driver will query diffuse for the pool and container information that it connects to, so they can access the file, the container directly through the DFS API. But you're gonna ask, is there really no way to have to run without diffuse mounted? Yes, there is some. There is a way to not require diffuse mounted and use some environment variable. It's not straightforward to use. So if somebody really doesn't want diffuse running on their compute node, which shouldn't be a problem, but if that's a requirement, we can discuss that offline if that's such use case is really needed. So some tunables to do with the MPIO driver that are not default on Aurora, and I think it's a good idea to set them. And we have compiled those. Technically, you only need the first two, basically. Just enable collective buffering. It's always a good idea. It avoids some pathological access patterns that can cause performance bottlenecks and things like that. So enable collective buffering, and that's done through the environment variable. Basically you create a file that has just these first two. You can add everything like the first 5. That's fine. But the most important part are the first two. If you know your application more, you can tune things like the collective buffer size, the collective the aggregators per node, and the striping unit. But those are not very important unless you really know what your application is doing. The first two are the most important. So once you create that file, it can be in Flare or Diffuse, Mount Point, or anything. You just export Romeo hints to that file, and Romeo will use these optimization. Does that make sense? Any questions? Am I going too fast? Okay, let's move on to HDF5. So as I said, Romeo, the MPI-IO is a building block for many IO libraries, and HDF5 is one of them. So HDF5 is, I think, as a library, very popular. A lot of applications use that. It was a question I wasn't know. It's usually most widely used. I've seen some statistics before, but yeah, it is very popular, and it supports parallel IO. It has a POSIX backend, like if you look at this graph here, by default it uses MPI-IO or POSIX. But if you have MPI and you load HDF5 on your compute node, it's parallel HDF5 basically. And HDF5 provides some useful tools on your HDF5 file to dump ls, diff, copy, and things like that. So today, what is recommended is that you use HDF5 with MPI-IO, and that's what's available today and what is recommended. The same advice that we talked about for MPI-IO applies for HDF5. It's the same sort of advice for best practices and things like that. The environment variables, what to use for MPI-IO, this applies to parallel HDF5 too. Many of you have heard probably that there is a new thing with HDF5, the latest version, called the VOL, the virtual object layer. We have worked with the HDF group before to implement a DAOS virtual object layer, DAOS connector, we call it. That's another way to access HDF5, and that's not POSIX based. So it's basically mapping the HDF5 data model to the DAOS lower level KB store, bypassing, there's no POSIX there. Today, that's not really recommended to use on Aurora because it hasn't seen much testing. I don't know if the vol is actually installed on Aurora, so it might not be available to use. So we still recommend to use MPI-IO for now, and just for if somebody is interested in experimentation and they want to write a paper or something to work with and want to test the vol, we can build it and we can test it and we can do some experiment. But for production use cases, for now, we're just gonna recommend keep going with the MPI-IO parallel HDF5 over the native POSIX. But this vol connector is something like can be selected just at runtime. It is similar to LD preload of interception library that we talked about with, but it's HDF5 specific environment variable, where you say, I want to use the DAOS vol connector and the path to the vol connector where you installed it. So, and then, HDF5 will use the vol connector, and if you're running on a diffuse mount, if your path to that HDF5 file is a diffuse mount point, you will actually see a file there, but it's not really that file that you are writing to. It's just what we call a stub file. It will be 0 size, and it will contain just an extended attribute which tells you the real path, the real location of that file, the pool and the container of that file. When using the vol, all the HDF5 tools will work fine. Also on the using the vol connector, but I don't want to go too much into that in details because we still recommend going using the regular POSIX MPI-IO backend there.